Hey guys, so it's Tuesday, the end of December 2015-ish, and I'm out here in the shop, and I'm doing some work on some stuff here. So I figured I'd just give you a quick update on what I'm working on, and basically, mounting my power supply for the 3D printer on the thing here. I gotta put some spacers behind here so it has a little better airflow. But that's done. I got to trim this down. This is the belt drive for underneath the bed, and in case you watched if you watched the last video, that was the bed that I'd milled out of plastic there, and this is a little bit as well. It's exactly 1/4 inch too long, so I'm going to cut a piece out of that with the jigsaw and glue it back together and see how that goes there. And probably the first thing I'll print on the 3D printer will be a replacement for this one here. Now next, well, what I've been working out here on is I've been doing some some routing with the CNC router here, and I was trying out a different bit. This is a Dremel bit, but it's pretty much exactly the same as these RotoZip bits, and it seemed to work quite well. You can see when I wasn't using the RotoZip bit, it was actually doing a lot of burning. What I was actually using was one of these burrs, and you can see it actually got a little blued because it got that hot, and that obviously wasn't good enough. There's way too much friction. I tried a simple router bit as well, and you can see it got a little hot as well. It's all full of sawdust though. Anyways, but these things seem to work quite well, apart from the fact that there is a fair bit of deflection on them. It's not, huge for something that you're making out of MDF, but, it's kind of hard to hold tolerances. It'd be nice to get a shorter one, maybe half the length of that one. And that'd be perfectly adequate for me. And as you can see, I was consistently having some problems with losing steps. Those are all supposed to be in a line. And even after I changed to the new bit, I thought it was because it was meeting too much resistance. I was still getting pretty much the exact same loss. So I cranked up the current in my control box on the y-axis and got much better results there. As you can see, those are all in line. And in case you're wondering, the corners are deliberately opened up. It's called T-boning them, or boning them, whatever it is. Something like that, boning them. And what that is that so you don't have to clean up the corners when you want a nice sharp edge, or so you can have something fit into it. And what I got that I want to fit into that is I was trying out something that I found online. It was called, there's a project out there called MT Snap. And that's, letter M, letter T, Snap. And it's something that the MIT guys did. And it was a snap together milling machine. It was a small one. Something about 1 foot by 1 foot by 1 foot, and that could do maybe a volume of 5 inches by 5 inches by, an inch or two. And primarily, used, or I think the primary idea was to use it for printed circuit board milling, but you could do small molds and that sort of thing. Anyways, but although that was interesting, what interested me more was the, snap part of the idea. And that is that they have two pieces that they want to snap together, and rather than using, say, something like these, furniture assembly screws like I'm using here on this machine, it literally just snaps together. And I thought that was so interesting, I wanted to try it out and see how well it worked. And actually, it's hard to do with one hand because you got to kind of help it a little bit here. But, here, let me just bend those pieces in. As you can see, they were hollowed out so that they could be a little bit more flexible at the base. It does kind of weaken them a bit, but I don't think it's the sort of thing you would ever want to take apart. But the idea being is that you literally snap it together, and now you've got a pretty solid connection. Like, I can't push it apart with my thumb and finger squeezing it to there. Holds in there, holds it fairly square, and or I'd say perfectly square. I can see a bit of a gap, and I think that's some of the, actually you probably can't, but I can see some gap on this edge, and that I believe is cutter deflection in the incredibly long bit. But in any case, I thought that technology was interesting, You can see it's pushed out there a little bit. But that technology or that idea was interesting because you would have a snap together thing without having to have to worry about any fasteners. Anyway, so I just tried that out today, and hey, check it out, MT snap. Now, what else am I working on? Well, nothing I'm supposed to be working on. Got to do oil changes on the cars. Got to do Vicky's Christmas present that I bought for her, which is a remote starter for her Honda Fit. That's going to be a little bit of work. Minimal amount of wiring, comparatively speaking, for some of those units. 12 wires, so I'll do some video of that when I get around to doing that. Hopefully sooner than later, because it's only getting colder now. Today was supposed to be fairly warm. I think it was going to be, about 6 Celsius, or what would that be? Somewhere just over 40 Fahrenheit, I think. So not too bad for around here, certainly for between Christmas and New Year. Anyways, guys, I'm gonna keep on this stuff. Get that done, cut this up, and glue it back together, and go from there. Oh, one thing I was gonna talk to you guys about, and I just was curious if anybody had done this. If this thing is looking a little foggy or dirty, I have to actually use the heat gun on my camera because the lens fogged up on me. But I saw on a channel called Click Spring, where the guy does a lot of clockwork, he actually had a metal cutting blade in his scroll saw, and he was actually cutting steel with it. And I thought that was pretty interesting. So if any of you guys want to do some high precision cutting and you don't have access to CNC or CNC plasma or anything like that, or CNC water jet or laser, whatever the hell you want to say, that was actually interesting. He was using a special metal cutting blade that I think they called it a jeweler's blade, and I thought that was interesting. Just so you guys, knew about it. Like I was, whether or not you guys knew about it or not, I don't know, but I was impressed by the idea. I always thought these things would be pretty good for cutting aluminum, even with a standard blade in these things. But the fact that you could cut steel with them was something that was new to me, so you guys might be interested to check that out. The channel was Click Spring. I think it was one word. And like I said, he does a lot of clock stuff, and he certainly doesn't need promotion from me. He has a way bigger channel than I do, but I just thought you guys might find that interesting, especially considering the fact that I think you can find these things on classifieds for, like 40, 50 bucks, so for anybody who wants to do some precision scroll work, it's a pretty cheap thing to get, and much better than a jigsaw. You want to make that distinction. Guys on eBay don't make that distinction, but there is a distinction. This is a scroll saw, and the one with the unsupported blade is the jigsaw. Anyways, guys, enough babbling. Stepping over things that I was assembling at Christmas, or after Christmas, or before Christmas, whatever it was. Just something I bought for myself that was on sale. Vicky and I really don't do too much Christmassy stuff. We had a very nice Christmas, though. We went and we tried something new. We went and we got a prime rib roast from Meat the Butcher in town, and rotisserie it on the barbecue, and it turned out fantastically delicious. It took about 3.5 hours on the barbecue, but it came out so tender it was impressive. And the funny thing was that I just saw a video from the Barbecue Pit Boys who were doing a prime rib on the grill, although they didn't rotisserie it. Anyways, guys, thanks for watching, and watch for some more videos soon. Thanks. And here's somebody keeping the amplifier nice and warm. Later, guys.